Alright guys, so today we are going to focus on solving right triangles. We have three different types of problems, three different types of right triangles, and we're going to use the rules that we've learned so far to solve for the missing sides. So for this first problem, I have a triangle. The entire triangle itself, it's not a right triangle, but if you look, it's broken up into two pieces with that altitude, that vertical blue line, and it creates a perpendicular line with this base, so it does give us a 90-degree angle here. If you're wondering where the missing side is, obviously, we have 11, this side is 12, this side says 7, but realistically, that 7 only covers from here to here, right? So that means we're actually looking for what's left, which would be this piece here. So we're actually looking here to find that space, right? So I noticed that this is not a special right triangle, meaning it's not a 30, 60, 90 or a 45, 45, 90. So that leaves me with, really one option, and that option would be the Pythagorean Theorem. Remember, Pythagorean Theorem, a squared plus b squared equals c squared. So first off, I'm looking for this side, but I kind of need some other information first. What I'd like to be able to do is kind of break this triangle into two pieces. The first piece being this triangle itself, and then this triangle here. If I can break it into those two pieces, what I can do is I can first find the length of this altitude, and then that would allow me to use this triangle. That was a terrible circle. That would allow me to use this triangle to find x. Right? So what I'm going to first do is break up that triangle first just by looking at the side with the 11 and the 7, and then the perpendicular line here is that blue line that was there, just so we're all on the same page. So first off, 11's, we'll call this y. So 7 squared plus y squared equals 11 squared. Well, 7 squared is 49, y squared is still y squared, and 11 squared is 121. So if I want to solve for y squared, I need to move 49 over by subtracting it from both sides. And this is going to cancel out. And I'm going to actually grab a calculator. Cool. So y squared equals 72. So, 72, not 7 squared. Sorry about that. So then from here, we're going to take the square root of both sides, and we get y equals the square root of 72. Now, what you can do is you can break it up. Break up 72. 72 is the same as 8 times 9, so the square root of 8 times 9. I can take the square root of 9, that would become 3. So y would equal 3 times the square root of 8, which, of course, the square root of 8 can be broken down as 2 square roots of 2, so really this is 6 square roots of 8, but I don't want to do that. I'm just going to throw this into a good old-fashioned calculator and come up with a decimal, right? If I can get my calculator to cooperate. So we have the square root of 72. That's going to be 8.48. And we'll just leave it as is here. 8.48. I'm not going to bother to round up. So I know what this blue line is now, and I'm just going to write it in. This is 8.48. So what I can do is take this triangle and draw it down here, which I'm going to do. Okay, so we have 8.48, 12, and x. So again, Pythagorean Theorem. Just going to move this up a little bit. So we have 8.48 squared plus x squared equals 12 squared. 8.48 squared is obviously going to be 72, because we literally just did that here, just kind of going backwards. Plus x squared equals 144. And then to find x, I would subtract 72 from both sides. And 144 minus 72 is 72. So then from here, to find x, we would just take the square root of both sides, right? And then x is going to equal 8.48. Weird how that worked out. But that would be our missing piece, 8.48. All right, moving on to our second problem here, which is a special right triangle. So it's a 45, 45, 90 right triangle. So we need to remember those rules. "45, 45, 90 degree right triangle" tells us that the two legs have a value of n, and the hypotenuse has a value of n times the square root of 2. So I'm just going to go ahead and label this. The two legs obviously come off this square, so n equals y, 8 also equals n, and then the hypotenuse is equal to n times the square root of 2. So I'm just going to go ahead and write those three things out here. I have n equals 8, n equals y, and n times the square root of 2 equals x. So what I'm trying to do is obviously solve for the missing legs, which would be x and y, pardon me. This is pretty simple. Obviously, I know that n is equal to 8, so I can take that and plug that in there, and I find that 8 also equals y, or y equals 8, however you want to look at it. Again, n equals 8. I can take 8 and plug it in here where I see this n as well, and this becomes 8 times the square root of 2, which will be equal to x. So pretty straightforward. Boom, I know my x and my y values. I'm not going to reduce that via decimal. I'm just going to leave it as is. So 8 is equal to y, and 8 squared to 2 is x. In the third example, as you can see here, I have a 30, 60, 90 degree right triangle. I know that this angle should be 60 degrees by default, because 30 plus 60 plus 90 equals 180. Okay, so we're going to remember the rules for a 30, 60, 90 degree right triangle, which tell me that the, pardon me, the leg that is across from 30 degrees, so all the way across, has to be equal to n. The leg that is across from 60 degrees, so all the way over here, has to be equal to n times the square root of 3. And then the hypotenuse is always 2n. Okay, I'm going to get rid of this so it's not so cluttered. But that's how we label our three sides. So I'm going to go ahead and throw these out here. I have n equals y. N square roots of 3 equals x. And 2n is equal to 10 times the square root of 6 over 3. Now, with a problem like this, you might be concerned, okay, where do I start? For this type of problem, what I would do is just go through each one and ask yourself, are there 2 letters? Yes. Okay, don't start there. Are there 2 letters? Yes. Okay, don't start there. Which leaves us with this. That's where we're starting. Okay, and so what I'm going to do is I'm going to solve for n, right? Solve for n and then plug it in. So I'm going to take this guy over here. I'm just going to rewrite it. 2n equals 10 times the square root of 6 divided by 3. And I'm going to go ahead and solve for n. Now, to solve for n, I need to get it by itself, which means I need to divide both sides by 2. So I have to divide a fraction by 2, which seems really confusing, but another way to think about it is when you're dividing by 2, you're actually multiplying by 1/2. And I can multiply fractions easier than I can divide them. It just makes more sense in my head that way. So either way, the 2 on this side will cancel, and I have n equals, we multiply straight across, so 10 square roots of 6 times 1 is 10 square roots of 6. In the denominator, 3 times 2 is 6. The only way to reduce this is to realize that 10 over 6, those are both even numbers, so it can be reduced. I can divide both of those, by 2. So I have 5 square roots of 6 over 3. So now I know what n equals. Great, that's my challenge. What does n equal? Well, I know, right? So I'm just going to go ahead and take what n equals and plug it in. So here I have 5 square roots of 6 over 3 equals y. That's the first leg. Easy, just plugged it in, no problem. The second one is to take the value for n again and plug it in. So I have n, which is 5 square roots of 6 over 3. And I need to multiply that by the square root of 3, and then that's going to equal x. So really all I'm doing is taking the square root of 6 times the square root of 3. I can multiply these guys no problem. 6 times 3 is 18, so this becomes 5 times the square root of 18 over 3. The square root of 18 can be broken down as 9 times 2, which I can take the square root of 9, that becomes 3. So this becomes 5 times 3 square roots of 2 divided by 3. I literally just took this and popped it in here instead of the square root of 18, just in case you weren't sure. And then the last thing to do is just multiply 5 times 3. So I have 15 square roots of 2 over 3. And then I said last thing, I lied. That's my bad. 15 divided by 3 is 5, so I can reduce. So I have 5 times the square root of 2, and that equals x, and that's the last thing. So I know my y value, which I found up here. I know my x value, and I'm done. All right. That was a review of all 3 methods for solving right triangles. Have a great day, guys.